Okay, so here we go for today. We're going to start with talking about vectors again, but this time we're going to be more focused on the 3D part than we have been. And there's actually two different ways to talk about vectors. And I also got to review some algebra with you. So here's what you're supposed to know so far. If I said this is vector A and this is vector B, would you just add them together and draw what it should look like? What does it look like when you add those together? You might be like, but can't tell exactly how long that is. No, I know. We'll get into that in a second. You're supposed to be able to take them from just pictures and draw them. And then we get more complicated and say exactly how far over does it go and how far up does it go. All right, so your A vector and your B vector should be added kind of like this. And you could have got this picture for your final answer. Raise your hand if yours looks something like that. Cool. Now, you could have added B to A, and you could have moved the A vector like over here, and I could have done it like that. And you know what ended up happening? The exact same answer. See how they are the same length, green resultants, and they're kind of going the same direction. So it doesn't matter whether you add B plus A or A plus B. Does that make sense? Okay, now let's make sure you get subtracting. I'm going to give you two different vectors. This is going to be vector R, and this is going to be vector T. And vector T is going to look like this, short and kind of at an angle like that. Okay, would you please do R minus T, and let's see if you know how that works. So here's R, and plus T would have been like this, so you don't do that. Instead, you go the exact opposite way. It's like that, and I'll do my resultant in green again. That green one would be your answer. Raise your hand if you had that one right. Okay, cool. Now, what if I were saying this in terms of, I already told you this way of doing it. Let's see if you get it. This one kind of seems to me like 5 to the right, but up 0. And this one seems to me to move 2 to the right and down 2. If you don't get what I mean by that, you could put in an axis like this, and you could sort of see, oh, I see, it is moving to the right and down on this T vector. And so do you understand what I mean by the 5, 0? And the 2, negative 2? Okay, then here's the last way we can write them. 5i plus 0j. If you can follow a pattern, what do you think we'd say for that one? Jody?
I don't know.
Okay, too early apparently.
I don't think that. I
Okay, I get it. Neil, take a guess.
2i minus 2j.
2i minus 2j. And it's kind of like this has just become the I-axis and this is the J-axis. It's kind of like X and Y. Why don't they just stick with X and Y? Well, because this is a whole new math system. And vectors is kind of its own little world. They get to make the rules. And vectors use I and J instead of X and Y. But I is like J. Sorry. I is like the X and J is like the Y. So, all right, so you could have thought of that as like 5x plus 0y, but we aren't using X and Y. We're using I and J. Yes?
Is there a reason why vectors need a whole new math system?
I'm sure there is, but I don't know that answer. I can't tell you why we can't use X and Y. I mean, we could. If you and I decided that in our little world for the rest of our life, we're going to do it this way. We could change it to X and Y. I mean, it's not like it's illegal. It's just that's not how the people who decide these things decided that, you know, it would be better if we don't use X and Y because it's different enough. There's some different things about vectors than there is about normal X and Y numbers. It's different enough that we should say this isn't the same, and therefore we aren't going to use X and Y, we're going to use I and J. Because in a normal math system, wouldn't this be like a point, 5, 0? And this isn't a point, it's a whole line with an arrow tip on it. You know what I mean? So it's definitely different than X and Y.
But then it kind of seems like polar, kind of,
But different than that too, because that's an R and a theta. So yeah, it's different. It's different enough to say it's a new system. Okay, so now, what if I just get a little more obscure and just say, since I just showed you what this means, what do you think 2i plus 3j would give you if you added it to 4i and 5j? This actually kind of makes sense if I had put it in column form versus, by the way, if I haven't told you already, this new way of writing it with the i's and the j's, this is called a position vector. If I just write them like this, it'll be pretty obvious. You just add the top ones and you get 6. And you add the bottom ones and you get 8. I often want to make a fraction bar. Don't let me ever do that. There's no bars between them. Here we go. 6, 8. What is that? Is that a point? No, it's a vector. It's a vector that goes 6 in the x direction. Well, it's not x. It's in the I direction. And it goes 8 in the y direction. So if I were to draw this picture again for you, it'd be a vector that goes 2 in the I and 3 in the j. That's like over 2 and up 3, so it's kind of like that. Gets added together with something that goes 4 in the x direction and 5 in the y direction. And they're very close to a straight line, but it's not actually straight. And then I can do the final answer is putting them together like this. No, the reason I know it's not actually straight because the slope of those isn't the same. That's the next thing we got to do is start talking about slope. There really isn't a slope in vector world, but there's something kind of like slope. And in the end, this one goes over 6, but up 8. Are you getting it so far? So the main new thing is that we have i's and j's. Well, now the next thing we're going to do, I bet you're going to guess what this means, is we're going to say like, okay, 4i plus 3j plus 2. Take a wild guess what I'm going to write next. Nobody's ever told you, but you can use logic.
Okay.
Yes. And now what the heck does that mean? It means 4, 3, 2. Well, how am I going to put that on a graph when I only have x and y? Well, you can't. You can go over 4. You can go up 3. But then from this moment, you have to go somehow 2 in a different dimension. That's why I've put up these strings in the classroom. So I want you to think of this as feet. 4 feet by 3 feet by 2 feet. And we're going to talk about it in the room. If you have to do this on a flat thing, then the k-axis comes out towards you and goes away from you. Okay, so this now, if I try to like, imagine this dot is coming straight at you. You wouldn't, if it was like a metal rod coming straight at you, you wouldn't even be able to see it because like it'd be right on top of the dot, you know? Like, and if it was going away from you, you also wouldn't be able to see it. So it's really hard for me to draw that, but it comes out off the page towards you or away from you. And which way is positive? Let's talk about that in the classroom here. So imagine we're going to get the point 4, 3, 2 in the room. And I'm going to go over 4 to the right. And then 3, you gotta figure this out. Where would this be in the room? I want you to stare at that spot. Where do you think we are in the room? Okay, now look away from the spot. And I'll want everybody staring at the ceiling. So imagine for a moment. There we go. This is the point. This little ball. Okay. I'm gonna go 4 to the right. 1 foot, 2 foot, red foot, blue foot. So 4 to the right. And then up 3. That seems like it's right on the ceiling. And then +2. Now some of you are gonna think that that's gonna move towards us, and some of it's gonna move away from us. Seriously, but it's half and half. People, if you had to guess at this point which way it's going, don't say it out loud, because I think that's gonna like bias people, like the first person to say it, you know. So let's just see if your gut was right. A lot of people are wrong. If it's +2, how many of you think that it goes here? Raise your hand if you were one of those people. Positive is towards you. A lot of people think that this is wrong and it doesn't make sense to them, but I would ask you this. If I dumped a whole bunch of money in the middle of the room and said, take what you want, just like tons of money in the room, you go over there and you pull it towards yourself, wouldn't you? That's a positive thing, right? My $100 bills. My brother actually did that with $1 bills. He got a few $1,000s. Somebody in the family passed away and they left him some money, and he's like, you know what? I think my kids could use it more right now than I could, so I'm gonna give it to them. So he took the bag of money, like cash, and they went to the bank, got $1 bills, so that it'd be impressive. You know, if you had only like $3,000 bills, it wouldn't be that cool, but you put like $3,000 on the kitchen table, dumped it out. And then somebody that knew them came into the house at the same time, and they're like, you guys like running drugs or something? Because who has giant piles of cash? So anyway, that was one of their fun days in the family. Yes, sir.
I just want to explain my reason behind it.
Okay.
Because when you look at a 2D graph, the x goes to the right.
Yeah.
So I thought like then if you once you have that 2D graph, and if you look at it and if you turn your head as if you're facing in the positive direction,
okay,
for the x, then the positive for it would be to your right again.
I see what you mean. If you imagine that this whole thing rotates one, chink, like this green line now is going this way. If you imagine that, then the z-axis would now be going out here. Yeah, I get what you're saying. It's a way to think of it.
I might be overthinking it, but
okay.
yeah, probably.
I don't think you're overthinking it. I think it's a good explanation. All right, so bottom line, if I say a point with 3 numbers, you gotta be able to know where it is. So I'm gonna say a point with 3 numbers. I'm gonna do it in feet again. And I want you to envision where it would be, okay? 1, 2, -3. 1, 2, -3. Should have been about back there. Raise your hand if you had that one right. Okay, good. I think you get it. It's going to be way harder to draw it, right? Because it's in 3D. So, that brings up an important point. You can make them in 3D if you want to make a cube in 3D. Everybody please draw a 3-dimensional box. If you're not good at it, which I'm clearly just proved I'm not, here's a way. You make a rectangle, or if you want to make it a cube, then make it a square. And then behind it, make an identical one, but just shifted back. And then connect the corners. And then if you want to make it look like you can't see through it, then you erase those lines. And you got yourself a 3D box. Okay? And the bad part about this box is that if you're going to make the z-axis come out towards you as positive, then you probably do want that to be your x-axis. And that to be your, this should be your x-axis. This should be your y-axis. And your z-axis is coming out towards us, and it's that line that we just erased right there. That way a point like 1, 2, 3, you'd go over 1, you go up 2, and then you'd come out 3 towards yourself. And again, it's really hard to envision where that point is in 3D space. Okay. This is where it is in 2D space if this is the y-axis and this is the x-axis, but then it has to come towards you for its last 3. Also known as I, or 1i, plus 2j, plus 3k. Yes, sir. Make it fast.
Just curious, would it work better if you like instead of like removing like the back part of the cube, you removed the front part so it looks like you're looking into the corner of a room?
You mean like x-axis and y and x-axis like that?
No, like still in the back corner. But,
Okay.
But it's the front. Like you cut open the box. Would that work?
I'm sure it would. All right, we're not going to have to draw much in 3D, so let's move on. But some people are naturally talented at 3D stuff like this, and some people are not. And I'm kind of in the middle. I can do it, but I'm not talented at it. Other people can just see in 3D. I think, for instance, Elon Musk is one of those people. He said before he can like visualize things in 3D, and then like in his head he can rotate them in 3D, and it all kind of makes sense to him, and you can do that. It helps a lot if you're an engineer. All right, so let's go into our notes here. Let's just make sure you would get this, and I'm going to add something to it. If this is 4 and this is 4, then how long's OC? I'm hoping you're good enough at finding that lengths like that. Because why? Because that is the magnitude. The magnitude is how long is that line. And then you got to be able to snap these out really quick. Go square root of 16 and 16. And if it's the longest side, you add them. Do you get how it's the square root of 32? Am I right on that? Okay, good. Square root of 32 is its magnitude. Can you have a negative magnitude? No. Can you have a negative direction and change direction? Yes. If you put a negative on a vector, you're changing its direction, not how long the line was. So there's no such thing as a negative distance, but there can be a negative direction. Negative just means opposite direction. If I say negative the magnitude, it just doesn't make any sense. Okay, you can subtract a weight, for example, but there's no such thing as a negative weight. There can be a direction, and you can go the opposite direction. That's what I'm trying to say. Okay, so, see, one of the things they're going to ask you to do is, in the homework for today, they're going to say, okay, if we know that the vector is going this way, then how would you represent the vector? Would it be 4, 4? No, think about it. If the vector is going this way, what would it be? Would you agree that if we slapped in an x and a y-axis, that that thing is going 4 to the left and down 4, negative 4, negative 4? Does that make sense to you? Because I put an arrow tip on it this way, then that's negative 4, negative 4. What I would always do is snug up a x and y axis right against the butt end of the vector. Okay, if you do that, if you place the not tip end, the whatever you'd call that, not the tip, I'm going to call it the butt end. If you put that right up against the x and y and put it right up against 0, 0, it's the easiest to tell. Oh yeah, it's going down and it's going left, so those are both negative. -4, -4. Make sense to you? Okay. How long is it though? Did the answer turn into negative something? No. The magnitude of this vector, call it vector m. Well, the magnitude of vector m would be square root of 32. Okay, let me give you another one real quick. Here's another vector, and it goes here. And I'll tell you that it's -3, 5. What's its magnitude? This is vector v, and it's that one right there. What's the magnitude of v? This has to go fast in your head because this is supposed to be the easy part. So this is 3 and this is 5, and then it goes square root of 3 squared and 5 squared. But one of those is bigger than the other, and we can't have it come out negative. Oh, it's positive anyway, so it's the longest side. So it's 25 plus 9. What's that make? Square root of 34. Raise your hand if you had square root of 34. Okay, good. All right. We're getting close to done, but I got to cover a couple concepts for you. In the old world of x and y, and we talked about a point that would go through like this, it would have a slope, right? Let's just do a slope between these 2 points. If this is the point 0, 2, and this is the point 4, 5, would you please tell me the slope between those two? Because vectors are a lot like this, right? It's just I and j axis, and it's not exactly the same, but it's a lot like that. All right, so what's the slope? The slope would be m. And were you doing 5 minus 2 over 4 minus 0? If so, you were doing it right. 3 over 4 is 3/4. Raise your hand if you had a slope of 3/4. Okay, cool. So do you get that you could also get slopes in 3D? What do we do for this slope? We just subtracted, this minus this. And then there was that minus that. There's going to be something comparable to slope in vectors, but we're not doing it today, but that's going to happen. Next thing is, when you have the slope, you could also write this thing as an equation of a line. We're also going to be able to do vectors as equation of a line between between this vector and that vector, like a point in vector space and another point in vector space, and we'll be able to write a vector between them. So can you tell me what the equation is for this? Hint, y minus y1 equals m times x minus x1. This is one of those moments where a top 20 skill is coming in, and if you don't know it, it's going to hurt you, and that's why I want you to have all these down before we started this class. Because this should be easy by now. Because we're now going to take this to the vector level. So, people that don't have it down, told you. All right. So then my point, well, I could pick either one. Hopefully you knew that. I'm going to pick 4, 5, and I would have y is 5, x is 4, and I'd have y minus 5 equals the slope, 3/4, times x minus 4. And that's an equation of the line through those 2 points. Would there be an equation for a vector that goes from one point to another? Yeah, it's going to be a lot like this. All right, last but not least, algebra skill-wise, if I give you two equations, 2x plus 3y equals 12, and 6x minus 3y is equal to Let me think. 36. Would you please solve this system of equations? Because we're going to have position vectors like this, and we're going to be figuring out the solution to a system of position vectors. Zodi, could you shut that door, please? Thank you. Okay. In case you forgot this way, it's a powerful way. You need to be able to solve things like this by doing elimination. Those two just drop right out. Those two make 8x, and those two make 48. Can you solve for x in your head? 8 times what makes 48? 6. See what just happened there? I think some of you are solving in a much more complicated way, but using elimination is a fast way to solve. So if x equals 6, then what's y equal to? Because you got to solve for both. Well, if x equals 6, I put that right here. 2 times 6 is 12, plus 3y equals 12. Ooh, that's not that hard. 12 plus something equals 12. That has to be 0. So y must be 0. And I got my point, 6 comma 0. All right. So there's a couple algebra skills that are going to be really handy for this unit. And the typical questions are now just asking you, like, do you know what this means? 2i plus 3j minus 6k added to 5i minus 4j plus 6k. And it's like a point in vector space and another point. No, it's a vector in vector space and another vector in vector space, and they're being added together. So remember, when it says 2, 3, and negative 6, let's look at that in the room. Where's positive 2? Up 3, it's pretty much right on the ceiling here. And negative 6, it's back about here. But remember, a vector isn't a point. A vector is going from 0, 0 to this point. It's like an arrow that goes from 0, 0 to this ball. Okay? And then it's going to get added to another vector. And they'll put them tip to tail, so it'll start right at that spot, and then go 5 in the I direction, which is like 5x, and then negative 4 in the J direction, that's the Y, so it goes down 4 feet. And then 6 in the K direction, which is back towards you. Well, it's right here. And then the final answer is that it's a vector that goes from the start of this whole thing, which would be at 0, 0, to where it ended up, which is right here. So my final vector is this. And what's it actually look like when we actually just add them together? Do you get that the 2 and the 5 would add up and make 7 in the I direction, which is like x? And these two make negative 1 in the J direction. And you could say 0 in the K direction. It just helps you see, oh, it's not going any in the K direction, which is like towards you and away from you. So this goes 7 over and down 1. So what was the final answer? It was like here, 7 over, down 1. And it's a vector goes from 0 to there. It's like a arrow. It goes Okay. Each little skill is important. You just should go and practice now, but not the normal way, because this time we're doing a Schoology quiz on what I just taught you and what we've learned for the last 3 days. It's in class, starting now. You can finish it at home. Okay, but everybody gets started on the Schoology quiz at this point. One of the first questions is going to use this. Remember, that means magnitude of. It means how long is that side. Use this sort of a method. If this is 3 and this is 4, this is the square root of 16 and 9, and that's the longest side. Yep, so then I add them. So that would be like, oh, 3, 4, 5, square root of 25, which is 5. Magnitude is the length of that side.